guys, how are yous? It's been a while. Grumpy Bandit here. We're going to continue our series today. And we're up here in Boston. We're at Logan International. We came in yesterday and we had to do our 100-hour service. We weren't keeping an eye on the ball and they pulled us up. So we did the service overnight. We are based out of New York City now. We're over at JFK Airport and we've actually set up a HBO there, which I'll tell you about later. But right now, let's get on with it. We are heading down to, where are we going today? We're going down to Tyndall Airport, Panama City in Florida. So I hope you guys enjoy the flight. I'm going to stick on my headphones and get the radio going and get the proceedings going. Enjoy the flight. It's going to be a night flight tonight. I hope you enjoy that. Something different. Yeah, so without further ado, let's get into it. Alrighty, let's turn this music down a wee bit here. Let me just get this kicking over and then we'll let's get some lights on in here and then let's turn on our beacon first. I'll turn on the nose light and APU's on. Get that music back once we're in the air, ladies and gentlemen. Alright, we can see what we're doing here. Okay, so the first thing I'm going to do is just go through our procedure here. Alrighty, let's, where are we? APU's on. Let's get our pumps on. Let's get hydraulics check. Let's put our auxiliary gens on. Let's get the fuel on. Alright, she's a little quiet. Let's turn up our audio. And I am running the Xbox version, guys. I had an absolute nightmare with the Steam version. And again, if you're new to the game, and you're on PC, I would definitely recommend that you buy the PC version. Yeah, because the Steam version, do not buy the Steam version. I've got it, and I'm going to have to buy I'm going to end up buying the Xbox version. It just runs so much better. It's just laggy as hell with Steam. But anyway, okay, let's get this thing started here. Engine fuel switches on, and let's get started. Let's get the wing light on for you so we can see the engine's booting up.
Boston ground American 53 Heavy requesting the end of pushback. Your flight will be monitored until American 53 Heavy requests to end pushback received. Boston ground American 53 Heavy with Echo ready to taxi IFR. American 53 Heavy taxi to an hold short of runway 4 right using taxiway Alpha Bravo Zulu Alpha Foxtrot Bravo Charlie Bravo Mike Cross runway 32. Contact tower.
Alright, while that's booting up, guys, I'm going to do a quick sim brief. I'll just plan it real quickly.
Taxi to and hold short runway 4 right using taxiway Alpha Bravo Zulu Alpha Foxtrot Bravo Charlie Bravo Mike Ross runway 32 American 53 heavy.
Alrighty, also let's make sure our simulated noise cancellations are off. We'll turn that on later once we're cruising. And we'll just get our crew on board. Our crew's just coming up the stairs now. And they're going to start loading our passengers. We will
Hello everyone. Captain and the entire crew would like to welcome you aboard on this aircraft. We are also getting ready for departure, which
Sorry
I would like
about
to
that,
ask
guys.
you to fasten your seatbelts. Make sure your seats are in the upright position. Tray tables are folded. Make sure your cabin carry-on items are properly stored. Once again, we would like to remind you that this is a non-smoking flight. So please refrain from smoking. Also, mobile systems should be set to airplane mode. Your cabin crew is here for your safety and comfort, and thank you for flying with us.
Alright, so we got crew bringing on passengers at the moment. We're going to set our departing position at Kilo Bravo Oscar Sierra. We're at gate, I don't even know what gate we're at, guys. Okay, we're going to send a request, so a sim brief. We're going to load that in. Bang. Activate that. Execute it. They've told us to leave. Hold short of runway 4R. Or right. Right there. Execute that.
Boston ground JetBlue 2322 request taxi to parking. JetBlue 2322 taxi to general
Check our
aviation
path.
parking using taxiway November. Cross runway 33 left November Alpha Echo Echo.
Alright, for Robert, we're going to load our speed brakes. APU's running, we'll turn that off.
General aviation parking using taxiway November. Cross runway 33 left November Alpha Echo Echo 1 Kilo JetBlue 2322.
That off. I think we'll turn our window heating on, and we will put our engine heat. It's a bit cold still here in the northern part of America, so we definitely want to be prepared for that. So I'm just going to put our anti-ice on auto, and then if we have some issues on the way up, it'll just kick in. But I'm going to put nav light on, logo, and I'll turn off wing. We'll chuck the strobe on before we go. Alright, let's get going here, guys. What else do we need to do here? I really should make myself a debriefing. I need a checklist, guys. I'm being lazy. I keep saying it. Every video I do, I'm like, gotta make a check-off list, because I get caught out. If we don't have we don't have a second pilot or assistant. It's very hard to remember everything. Alright, let's get our lighting sorted out. Okay, I keep everything quite dim. Excuse me, let's, I think we're ready to go.
Ladies and gentlemen, on behalf of the captain and the entire crew, welcome aboard. Now we request your full attention as the flight attendants demonstrate the safety features of this aircraft. When the seat belt sign illuminates, you must fasten your seat belt. Insert the metal fittings one into the other, and tighten by pulling on the loose end of the strap. To release your seat belt, lift the upper portion of the buckle. We suggest that you keep your seat belt fastened throughout the flight, as we may experience turbulence. There are several emergency exits on this aircraft. Please take a few moments now to locate your nearest exit. In some cases, your nearest exit may be behind you. If we need to evacuate the aircraft, floor-level lighting will guide you towards the exit. Doors can be opened by moving the handle in the direction of the arrow. Each door is equipped with an inflatable slide which may also be detached and used as a life raft. Oxygen and the air pressure are always being monitored. In the event of a decompression, an oxygen mask will automatically appear in front of you. To start the flow of oxygen, pull the mask towards you. Place it firmly over your nose and mouth, secure the elastic band behind your head, and breathe normally. Although the bag does not inflate, oxygen is flowing to the mask. If you are traveling with a child or someone who requires assistance, secure your mask on first, and then assist the other person. Keep your mask on until a uniformed crew member advises you to remove it. In the event of an emergency, please assume the bracing position. Lean forward with your hands on top of your head and your elbows against your thighs. Ensure your feet are flat on the floor. A life vest is located in a pouch under your seat or between the armrests. When instructed to do so, open the plastic pouch and remove the vest. Slip it over your head. Pass the straps around your waist and adjust at the front. To inflate the vest, pull firmly on the red cord, only when leaving the aircraft. If you need to refill the vest, blow into the mouthpieces. Use the whistle and light to attract attention. Also, your seat bottom cushion can be used as a flotation device. Pull the cushion from the seat, slip your arms into the straps, and hug the cushion to your chest.
Sorry about that.
At this time, your portable electronic devices must be set to airplane mode until an announcement is made upon arrival. We remind you that this is a non-smoking flight. Tampering with, disabling, or destroying the smoke detectors located in the lavatories is prohibited by law. You will find this and all the other safety information in the card located in the seat pocket in front of you. We strongly suggest you read it before takeoff. If you have any questions, please don't hesitate to ask one of our crew members. We wish you all an enjoyable flight.
Alright, so they want us on, let's just double check this for right. Just got to find our runway here. I think I know where 4 right is. Okay, yep, alright, I know where it is. Very clear on the map, but let's do it. Let's get out of here. Just ignore that. Someone's obviously had a few drinks tonight.
Roger, American. 5-3 heavy.
Crew, prepare for takeoff. Got a plane coming in to land here, chat. We'll just keep an eye on him. Where on earth is this man going? He's landing on the... Oh, he's landing here, nice. Oh, okay, so they got him landing on that one. I thought he was gonna wreck. Nice landing, son. That's us, guys. Let's get out of here.
Cleared for takeoff runway 4 right American 53 heavy.
Flaps 15, just double checking. Little bit of bloody frames going on there. Okay, let's prime her up. Strobe on. Let's do it, chat. B1. Rotate.
Airborne time locked.
Gear up. FD on.
Going to 133.0 American 52 heavy. Boston departure American 52 heavy is passing 2,000 feet, climbing 11,000
Flap 1 up.
feet.
American 52 heavy Boston departure altimeter 29.48 continuous planned.
Flap 2. Flaps up. See you later, Boston. Boston. EP on. Auto throttle on.
American Flight 2 Heavy contact Boston Center on 133.325. Good day.
133.325 for American 5-2 Heavy. Boston Center American 5-2 Heavy is passing 9,000 feet, climbing 11,000 feet.
Excuse me, chap. Just focusing on the job here. Do we break through?
American Flight 2 Heavy contact Boston departure on 133.0. Good day.
133.0 American 5-2 Heavy.
Keep an eye on our auto throttle.
2 Heavy is at 10,200 feet, climbing 11,000 feet.
Something's
American Flight 2
little fishy there.
departure altimeter 29.4.
About to break out here, guys. I think we have very dark.
Good day.
Okay, let's kill our landing lines.
For American 5-2 Heavy.
Let's set our...
Center American 5-2 Heavy, 11,100 feet.
Alright, we'll set straight to 37 now, so we're not...
2 Heavy Boston Center altimeter 29.4. Continue to be AYYS as planned. American Flight 2 Heavy climb and maintain flight level 180.
Climb and maintain flight level 180 American 5-2 Heavy.
Very dark, guys. We've got a lot of cloud, that's why you can't see the city, so sorry about that. Not much to see on this one till we start getting some warmer weather. Just running the audio a little hotter today, guys. I'm just experimenting, getting it right for you. And I encourage you guys to put it on the big screen at home, because the quality that we're recording at is absolutely brilliant for a live stream. It's amazing. I am over at Twitch/Grumpy Bandit. We get up to some shenanigans over there. I stream some other games, but I will be focusing my simulators on YouTube, purely for the quality. And I appreciate you all tuning in. If you enjoy it, hit that subscribe button. I'm trying to build our channel. I'd like to get a couple thousand subscribers by the middle of the year is my goal, and I can't do it without your help. And we'll be putting a lot more content, a lot more reviews. I'm in the throes of moving from Australia to America, so I've been a little inconsistent at the minute, but once we get settled over there, we'll start getting a bit more consistent with our uploads. Alright, I'm just keeping an eye on things until we hit our ceiling height. And then I'll probably go AFK for a little bit and leave it with yous.
American 52 heavy contact Boston Center on 124.85. Good day.
So far so good, everything's running beautiful, man. My trusty old 777. Good.
American 52 heavy Boston Center altimeter 29.49er. Continue to Bay this plan. American 52 heavy climb and maintain flight level 240.
Alright, so we're heading towards JFK, New York City.
Flight level 240 American 52 heavy.
We're going to be flying right over our HBO, so we have set up... hang on, guys. Let's just turn our simulated sound cancellers on. I can turn this music down for you. There we go. So it's quite a difference when we jump out. Beautiful. Move my controller now. Everything's going to be up to the autopilot until we get about 150 nautical miles out of our location down there in Panama, where the weather is fairly toasty. Let's get a weather report for you. Have a look. KPAM is where we're off. Kilo Papa Alpha. Okay, let's have a look. The skies are clear. Beautiful. 17 degrees Celsius. Nice. Means it's going to be toasty tomorrow. So it's currently 17 degrees. So it's beautiful weather down there in Florida, guys. So those guys who've been freezing their bums off up here in the north, hope you enjoy it down there. Alright, let's just check on some few things here, see if we can nip our speed up a little bit. Try and get to our 500 nautical mile an hour. Very fast plane, this one, for its size. I think we might go up to 38 today, Jet.
JetBlue 1922 to your tree 2 miles south. Descend and maintain 6,000 feet. Keep speed not above 210 knots. Expect ILS runway 4 right approach by Gashi transition. Clear to Gashi. Descend and maintain 6,000 feet. Keep speed not above 210 knots. Expect ILS runway 4 right.
Well, they're telling us to hold. I'll hold at 240 so we don't break any bloody rules here because we're coming over.
Contact Boston approach on 127.2. Good day. American 52 heavy climb and maintain flight level 360.
Right, they're telling us to keep going. This is
Climb
great.
and maintain flight level 360 American 52 heavy.
360.
127.2 for JetBlue 1922.
So we are Emu Airlines, guys, but we are flying contract for American Air tonight. So our company, OnAir company, is Emu Air. If you're interested in, you guys are doing Emu Air and you want to run some do some more jobs for us, you can contact us on air. Just check out Emu Air.
Delta 419er, you are 50 miles southwest. Descend and maintain 2,000 feet. Expect vectors, visual runway 4 left approach.
Descend and maintain 2,000 feet. Expect vectors. Visual runway 4 left approach. Delta 419er.
Ladies and gentlemen, the captain has turned off the fasten seat belt sign. For your continued safety, we would like you to keep your seat belt fastened at all times while seated.
United 352, you are 65 miles southwest. Descend and maintain 3,000 feet. Expect vectors, visual runway 4 left approach. Descend and maintain 2,000 feet. Expect vectors, visual runway 4 left approach. United 352. approach via Papa Uniform Tango transition. Cleared to Papa Uniform Tango.
Descend and maintain 2,700 feet. Expect ILS runway 29er approach via Papa Uniform Tango transition. Cleared to Papa Uniform Tango JetBlue 676.
Boston Center KLM 644 is at flight level 2905, descending 10,000 feet. KLM 644 Boston Center, continue as planned. JetBlue 676, contact Boston Center on 127.65. Good day.
Boston Center SkyWest Tree 167 is passing 15,800 feet, descending 2,200 feet.
SkyWest 3167, Boston Center altimeter 29er.54, continue to Papa Uniform Tango as planned.
127.65 for JetBlue 676.
Stop.
American 52 Heavy, contact Boston Center on 128.1. Good day.
Going to 128.1 American 52 Heavy. Boston Center American 52 Heavy is passing flight level 340, climbing flight level 360.
American 52 Heavy, Boston Center, continue to Bay East as planned.
Find and maintain flight level tree 70 American 52 heavy.
Decimal tree 5 Delta 2542.
Alright guys, we have
Maintain 10,000 feet.
hit our ceiling height here. I'm going to set us to Mach 86, which is top speed for us.
4 decimal 5, 25 jet,
Well, it's not top speed, but it's top safe speed and also economical. So it's pretty fast. About 500. What is it, about 500 ground speed? Maybe more, depending on the weather.
Delta 2542 Boston Center altimeter 29.56.
Okay, I'll give the crew a little bit of light here. They can do their things, plan our approach and landing. I'm going to chill out, go and have a cup of tea. Probably go and talk to the girls down the back. You guys enjoy, and I'll be checking up intermittently.
Good day. Decimal 85 for Delta 2542.
124 decimal 85 for Speedbird 188.
Ladies and gentlemen, we will shortly be passing through with food and drink. Please check the magazine in front of you for the full menu as well as our duty-free offers. Thank you.
American 5, 2 heavy contact Boston Center on 1 tree, 2 decimal tree. Good day.
1 tree, 2 decimal tree for American 5, 2 heavy. Boston Center, American 5, 2 heavy flight level
Well,
370.
let's dive in. If the internet's like the ocean, the web we know is the surface. The deep web's larger and houses things like password-protected medical data, bank web pages and company intranets. And way down here is the dark web. Originally for dissidents and activists, the dark web also attracts cyber criminals and drug dealers. Hard to get to, but easy to hide in. The dark web's a pretty dark place. Find out more, because evolving threats demand evolving protection.
We gotta watch that dark web, chat. Watch the dark web. God forbid they don't track any of your information. Anyway, we're going to put some in-flight entertainment on for you, ladies and gentlemen. Hope you enjoy. Sorry about the ads. Someone's got to pay for the platform.
Brickyard 583, 6 contact Boston Center on 128 decimal 1.
It would be one of the most complex machines ever built. It would take 10,000 people and nearly 5 years to build it.
128 decimal 1 for
It would cost an estimated $5 billion. Success was anything but certain. The plane would contain more than 4 million parts, supplied by contractors around the world. But would they arrive on time?
Miss your first commitment and then things start to go wrong.
And would they work?
From a technical point of view, I would not put this back on the airplane if I had a choice.
Nothing could be left to chance. This would be the most tested airliner in aviation history. Eventually, lives would be at stake.
There's an apprehension anytime you change technology.
To make it all work, the company would reinvent itself from the inside out. And all of this would have to happen at a time when the world's airline industry was in recession. If the 777 were to fail, the company's future was at risk. Success would keep Boeing ahead of the competition for decades to come. This plane would be built to set a new standard for commercial aviation. This is the story of the building of a 21st century jet.
I'm sorry, I thought that was...
300 people are boarding a flight from London to Washington, D.C. It's actually an inaugural flight, although most of these people didn't know it when they bought their tickets.
This just happened to be the day we needed to go back to Washington, and the secretary made the flight. I don't think she knew it was the inaugural flight, so just pure coincidence.
This is the first commercial flight by United Airlines of a brand new airliner, the Boeing 777. The chances are that anyone who travels to Europe or Asia will sooner or later fly in the 777, as this plane replaces the older 747s on many overseas flights. It's Boeing's 7th new airliner, and the company has staked its future on it. In economic hard times for the airline industry, Boeing hopes the 777 will keep the company prosperous well into the 21st century.
To put it on, flip it over your head.
But the investment and the risk are enormous. For the last 3 years, we've been following the process of designing, manufacturing, and testing the world's largest and newest twin-engine airliner. It's cost an estimated $5 billion. Boeing needs to sell 200 or so planes at roughly $100 million apiece before the company will consider the plane a success. Back in mid-1992, Boeing began assembling and training the 10,000-strong team whose excitement and disappointments would punctuate the complex process of plane making.
How are you?
A key figure in this drama was Alan Mullally, the 777 director of engineering. He had a boyish charisma, a fierce pride in his company, and he was determined that the new plane would succeed.
Best airplane company in the world.
But in the time since Boeing had developed its last airliner, the aviation industry had changed. It had become harder to hold on to a share of the market.
What's different with the airlines? They have choices. They have choices. They haven't had so many choices before. All except the 747. Airbus has an airplane that can match every one of the Boeing airplanes. So they have choices for the first time in history.
This new competition had come about because of a gap that opened up in the commercial aviation market. The airlines wanted a long-range plane that was smaller than Boeing's 747, so Boeing's two rivals started manufacturing new planes to fill that gap. Airbus with its A330 and 340, and McDonnell Douglas with the MD-11 and 12. The 777 comes somewhere between a 767, a 200-seater, and a 747, which can carry up to 425 passengers. When the company first decided to enter the race, they hoped they could expand the 767 in ways that would satisfy their customers. Boeing took these designs to various airlines. No one was impressed. British Airways, for example, dubbed this a chipolata sausage. In October 1988, the design team met with Boeing's senior executives.
New York Center
we had, at that time, I think 7 product scenarios, all focused on a 767 derivative. And at the end of that 5-hour meeting, the simple question was asked, why haven't you looked at a new airplane? And our answer was, we really haven't done it yet. We'll go do the homework. And the next question was, when can we look at some data? And the answer was the last day before Christmas break in 1988. So we went back to our team, which at this time was about 200 people, and said, let's start working on a new airplane.
Boeing had done all this before. From its base in and around Seattle, the company had designed and built 6 different airplanes for the world's airlines. By the end of 1988, they had decided it was time for a 7th, in spite of the huge financial risk this involved. And the risk would increase over the following years as the world moved deeper into economic recession. When President Clinton visited the Boeing plant early in 1993, he reminded the assembled workers of how bad things were for the airline industry.
And it is indeed ironic that the United States, which for so long has led the world in the production of airplanes, has had 3 years in which more money has been lost than was made in the previous history of the airline industry.
The economic situation would prove a constant source of anxiety for the plane makers as they got underway on the 777. Particularly for the executive in charge.
I was a young engineer here in 1969, when 2/3 of the Boeing population left during the period when there was a big sign outside that said, outside of Seattle, it said, "Last person out, please turn out the lights." That clearly has affected the way I think about organizations and stability of organizations. Be more careful when you're going up, because on the other side of up is always down. We went up way too fast. We weren't efficient in the process, and so when we got to the top, we were way overmanned, and the far side was very steep. Don't want to ever do that again.
To justify the huge investment in the new plane, Boeing needed a launch customer, an airline that would commit to buying a significant number of the new planes in advance. They naturally turned to United Airlines. The two companies had been partners in the early days of commercial aviation. This is United's first Boeing airplane, the earliest all-metal transcontinental passenger airliner. The company has since bought more than 1,000 Boeing airplanes. But the historical relationship between the two companies counted for little when it came time to make the deal. Gordon McKinsey of United.
So we went through a rather large evaluation process in 1989 and 1990, where we were looking at 33 combinations of airplanes and engines for our wide-body purchase. And this was just one of the candidates. The 777 was up against the Airbus and the McDonnell Douglas airplanes.
The sales campaign came to a head on the weekend of October 13th, 1990, when all 3 manufacturers, Boeing, Airbus, and McDonnell Douglas, were summoned to United headquarters in Chicago to make their pitches. Boeing was asked to sign this handwritten piece of paper. It played a crucial role in the decision, as Alan Mullally would later tell the 777 team.
It's a piece of paper that Jim Guyette, who's Executive Vice President of United Airlines, wrote at 2:15 in the morning. He woke up in a cold sweat. He's going to walk in and see Mr. Wolf, who's the chairman of the board of United. He had the chief financial officer that was voting for Airbus instead of Boeing, and he had to walk in and make his vote. What airplane should United Airlines go with for the next 30 years?
It was a hard-headed and unsentimental business, with each of the 3 competitors in separate rooms, running in and out of a room full of senior United executives who were trying to make up their minds. An executive named Dick Albrecht led the Boeing sales force. Phil Condit, as leader of the 777 team, wondered whether he should go to Chicago too.
I talked to Dick Albrecht, said, do you need me there? And his answer, and I believe correctly, was no, I think we've got our pieces. We'll go try to put the deal together. So I said, okay, well, here's my phone number. I'm gonna be at my younger daughter's parents' weekend at Colgate University. And I'm available by phone. I'll check in.
Well, it was emotional because when we went in there, I think it was a Thursday morning, we were told by the senior VP of Finance that we weren't leaving that building until the deal was done. So we'd all checked into local hotels, and we were there watching the sun rise over our corporate headquarters twice.
After a while, I was reasonably certain that the phone was probably broken because it didn't ring. Sitting there watching it, nothing happened. So I called Chicago. And they said, we're just sitting here, but we expect something in the next couple hours.
We went into 70 hours of nonstop negotiations. And it was very emotional because we could tell by the faces on the people coming out of the Inquisition chamber that things had not gone well. What was happening, of course, is, somebody would go in there from one manufacturer, and a deal would be presented, and then he would be dismissed, and the next person would come in, would try to better the deal. So it was a ratcheting process through those 70 hours, trying to get the best terms.
So finally, at the end of the day, things were still sort of not to happen. I said, I can't stand this anymore. I got on the airplane, went to Chicago, and went and joined the wait. Sat and talked and worked on a crossword puzzle.
Technically, we had made our decision. We knew what we wanted to do. So we had our technical recommendations already in place. And the 70 hours were really just financial negotiations, terms and conditions, a lot of contract talk. But it was emotional.
Then they sort of finally came in and said, well, we need to see you in Jack Pope's office. So we went down there and they said, you've got the deal. I was glad I was there, and it was exciting to be there. My contribution probably can be measured in very small numbers at that point. It was just being there.
What clinched the deal was the agreement put in front of Boeing by Jim Guyette.
So he wrote a handwritten note at 2:15 in the morning saying things like, we agree to work together, really complicated words, to deliver a service-ready airplane, an airplane that works. It has the functionality, the passengers like it, the attendants like it, the maintenance people like it, the flight crew likes it, and we agree to work together to make that happen. And then he dragged Phil Condit and Dick Albrecht into the room, and he said, will you sign this? And they said, and he took that to Mr. Wolf, and he said, this is the new Boeing. The new Boeing is going to treat us at a new level of respect as a customer. The reason I wanted you to know this is that meeting at 2:30 in the morning has changed my life. And it's going to change yours. I've been waiting for 4 years for you to arrive because it's time to make an airplane.
United Airlines agreed to buy 34 777s for delivery in 1995 and to take an option on another 34 for delivery 3 years later. They had committed to spending $3.5 billion on a plane that didn't yet exist. The plane United bought would have a number of important features. It would be powered by just 2 large engines. It would be guided by a state-of-the-art electronic control system, and it would be built from the newest and most reliable materials. It would also be a very big airplane. Not quite a jumbo, but not far from it. The diameter of the engine would be as wide as the whole fuselage of a 737, and the horizontal tail would be equal to the 737's wing. But it was the interior of the plane that most interested the customer. To show off the interior layout, Boeing spent hundreds of thousands of dollars on a life-sized mock-up. It would be an essential sales tool, Early on, Lord King, chairman of British Airways, was given a guided tour.
Hello.
Lord King is shown an important area at the back of the mock-up, called by salesmen the dirty pool, with an emphasis on how the 777 would compare with the competition.
So all the wide bodies flying today, because what we were after was, you said make it bigger and make it roomier. Well, this is what people are used to flying. Here's the contour, and here's the bends. Here are the bends. Here's the 777, the 5 inches larger. You can see the contour, and then the effect of the bend. Okay,
All right, let's
look at the back.
In previous Boeing planes, full-scale mock-ups of the aircraft, inside and out, were not just marketing tools. They performed an important role in the design process. With the 747, for example, Boeing built several life-size mock-ups of the whole plane, with every part modeled in detail before the design was finalized. It was the only way the engineers could see whether or not the pieces fit together. Because of the three-dimensional complexity of the plane, a component as first designed often got in the way of the structure or one of the other parts, like these red pipes, which are not meant to go through the yellow duct. With the 777, Boeing wanted to find ways to catch these interferences, as they're called, before the assembly stage.
You have 5,000 engineers designing the airplane. It's very difficult for those engineers to coordinate with two-dimensional pieces of paper. For a designer who's designing an air conditioning duct to walk over to somebody designing structure and say, now here's my duct, how does it match up with your structure? And they've got two-dimensional pictures, very difficult. So we ended up using the mock-up and, quite honestly, the final assembly line to finish up the integration. And it's very costly. You end up with an airplane that's very difficult to build.
It all has to do with visualizing 3 dimensions on a 2-dimensional drawing board. One of the trickiest problems was working out the lengths and angles of tubes, pipes, and wires.
We would literally, physically thread the systems through that mock-up, and then, in the wire bundle sense, take it out of the mock-up, flatten it on the board, measure it, and that's the way we decided how long the wire needed to be. And then you would adjust as necessary, because the airplane, not made of plywood and aluminum, differs from the mock-up. So as you produce those first wire bundles, then you make further adjustments to make them fit the real airplane. Hydraulic tube, a very similar situation.
The solution was a secret weapon called EPIC, a computerized design system that would require 8 mainframe computers to run it. Engineers would be able to roam the virtual interior of a plane that didn't yet exist. As pieces were designed, they appeared in the virtual airplane next to other components, and the team could check to see that they all fit together before they were carved out of metal.
So for the first time, the engineering creative process was enabled to think in terms of the way the world is, in terms of 3 dimensions. Now, computers don't design airplanes. We have not put the knowledge that's in the airplane designer's head into artificial intelligence that balances all these objectives. Someday, we'll continue to probably move to that end, but right now, the knowledge to design airplanes is in the designer's head.
There would be more than 2,000 computer terminals, so that each group of designers could feed their drawings into the main computers. In June 1992, the passenger doors team was checking for interferences in the components they had designed. An interference showed up in red. The designer was concerned about 2 crucial components in the door hinge.
This splined part right here, there's a bolt passing through it. It's actually the connection of the door to the door frame, the cutout. And this bolt affects that connection. Somewhere inside there, we've broken some law. Now that looks like a real interference. This is what happens when you accommodate your stress man's desire that they be intimate. interfere for the entire head of that bolt. But the actual amount it interferes, we really tell by cutting through the two of them and looking at an accurate cut, which doesn't take hardly any time at all. Now this, yes, the second circle is just a little bit larger than the first circle, and I do indeed have a little problem here. But it's a very small one. We haven't released any drawings yet.
Another innovation on the 777 would be a new method of organizing the 10,000 or so people building the plane. On past projects, airplane design had been bedeviled by communication problems between the many different divisions in the company. For the 777, Boeing would create new work groups called Design Build Teams, or DBTs. They would include people who had never before worked together.
I wish that I could say that design build teams were sort of one of these wonderful ideas that sort of leapt forward and you said, aha. In a lot of ways, it is a return to some things that have worked in the past that were scale driven. If you go back to the early airplanes that Boeing built, the factory was on the bottom floor, engineering was on the upper floor. Both manufacturing and engineering went back and forth. When there was a problem in the factory, the engineer went down and looked at it and said, well, you better do this. The entire design department was within 50 feet of each other. As the scale went, that gets harder and harder and harder. And if you're not careful, organization, just by the way they behave, want to form little enclaves. So structures goes off over here, and air conditioning goes off over there, manufacturing goes over here, and planning goes over there, and finance goes over there. And then one day you turn around and you've discovered there's an us and them attitude. If only they would do this, then our job would be easier, and if only they would do this.
The passenger doors were designed by one of over 200 design build teams, each responsible for a major component. Making an airplane door that works involves the complex interaction of geometry, materials, manufacturing, and in-service maintenance. At one point, this team faced a problem that brought up all these factors.
That's a full-size drawing of the two cutouts in the door skin that are located very closely together. Again, our principal concern is making sure that with all of the parts that have to be integrated into this area, fasteners that have to be put in the skin, do we have enough room to do all of that, and will the assembly be durable and damage tolerant?
The problem involved a metal area of the door skin between the window and the door handle cutout that was uncomfortably narrow. The designers have two questions. How strong a force would produce a crack in this area? And if the metal did crack, what force could enlarge it and lead to the door failing? They get two different figures from the stress analysis engineers. It would take a force of 27,000 pounds per square inch to crack the metal. But once a crack had formed, the force of 12,000 pounds would be enough to open it up.
That's the way we perceive the situation. 12 is the upper limit at which crack will not grow. And in this area, there's not much room for a crack to grow. We're very tight.
I guess the problem, what's still not clear in my mind is, for the identical area under the identical consideration, are you getting a recommendation of 12 from one guy and 27 from another?
Yes, for two different reasons.
Right. And if you follow the first guy, you would in all cases restrict the stress to 12. Yes. And the second guy says, as far as he's concerned, you could go to 27, but he's not considering the other requirement.
That's correct.
Okay.
That's correct. We could work it to 27, but if a crack should start, it's going to grow right across the area. Okay. If we hold it to 12, it immediately satisfies the area. Okay. That's all we're saying.
There were four possible fixes involving thickening the existing metal or adding an extra layer called the doubler. However, since any cracks would be easily visible, Perhaps they could just ask the airline to keep a lookout.
Just call for a special inspection in that area. That's an alternative.
True.
Not pleasant, agreed.
Right.
It's
So
an alternative.
especially since we've already told United we won't have any of those.
That's right. But this happens to be on a door that gets frequently used. The number 4 door is supposed to be one of the most frequently accessed for loading the aft galleys and so forth. It may not be much to have an experienced person show up there every so often and just take a close look instead of having to have something leap out at you and say, I'm a crack, I'm a crack.
I understand.
It took another 4 months to solve the problem entirely by designing an extra layer called a doubler to go behind the outer skin.
If we just left it a skin without this doubler here, it may be strong enough for static strength, meaning it can take the pressure of the airplane, but over repeated pressurizations, eventually it would get tired, it would fatigue, it would crack, and the crack would then go across here. The airlines would catch the crack, and then they'd have a very difficult maintenance job to go in and repair it, perhaps putting the doubler, maybe one like this, on the outside, which then is drag and etc. So it pays us to figure this all out ahead of time and put it in behind.
In mid-1992, while the team was still designing the door, they built a prototype for a very important cold weather safety test. The engineers wanted to see if the door could be opened in the worst imaginable conditions of icing on the outside of the fuselage. The first stage of the test involved spraying the door with water all night in a low-temperature chamber until there was a thick layer of ice. But how could a plane ever get into such a state?
If the plane lands from a cold flight, minus 65, and comes into an airport where, let's say, it's about 28 degrees, there's freezing rain, and it pulls up to the gate, and this freezing rain is then adhered to the outside of the airplane, we need to make sure that we can open the doors. Our criteria is a 1/4 inch thick of ice all over the whole airplane, and yet at the same time, someone with nominal handle force on the inside can indeed open the door. We consider the ice to be as strong as 100 pounds per square inch to break it. It's a 1/4 inch thick, and there's about 200 or so inches of ice around there. So when you factor all that in with safety factors, it's about 6,000 pounds of lift that has to be put on the door to make sure we break all the ice. And that has to be put in with about 50 pounds of handle force on the inside.
The following morning, the door had acquired a thick enough layer of ice to test the mechanism.
It's minus 20 in there right now. It was minus 55 in there yesterday when we sprayed the water to make sure it iced up. Considerably colder yesterday. Minus 20 is not so bad.
This test had never been done before on this door design. If it didn't work, the engineers would have to redesign the complicated opening mechanism inside the door.
Boy, it's nice. This is a big key test, and it worked great. Feel real good about it. Right.
Another part of the plane that was being tested long before the 777 existed was the flight control system. Boeing equipped one of its smaller planes, this 757, with a prototype of a brand new system that would be used in the 777. They had to test it in flight.
Right now I'm holding a lot of column force.
These tests came after many months of testing in simulators on the ground. The new system was called fly-by-wire.
I go to 10,000 feet and about 250 knots.
fly-by-wire is an unfortunate term. Probably electronic flight control system is as close as you can come to the real definition. But it's simply the idea that we use electrical wires rather than mechanical cables to transfer signals from the front end to the back end of the airplane.
Boeing's chief test pilot for the 777 was John Cashman. He would be the first to fly the plane once it was built. He quickly understood the advance that fly-by-wire represented over the more cumbersome system then in use.
An airplane, particularly a large airplane, has large cables that run from the cockpit controls to the actuators that move the surfaces. And almost all big airplanes are hydraulically moving the controls. Those large cable runs are very difficult to rig and very time-consuming to maintain them in rig. So from a maintenance side, it's a fairly big improvement in terms of time to maintain. The changes that one can make and improvements that you can add to an airplane are much easily done if it's a computer card change versus a mechanical redesign.
There's a pilot's joke about fly-by-wire systems that says that modern planes could be flown by a pilot and a dog. The dog to bite the pilot if he touches the controls, and the pilot to feed the dog. In fact, the computer systems that would be installed in the 777 were so intelligent that engineers believed they could make decisions that would be as good as those made by the pilot. But Boeing stopped short of letting computers fly the plane. It was a question of safety.
The biggest disadvantage from a safety point of view is the potential that you haven't thought clearly through all of the events that may occur and taken enough precaution. There's an apprehension anytime you change technology, and particularly when you switch from mechanical, which is visible, to electrical, which is not. And so to some extent we've taken a conservative approach to make the airplane fly like a conventional airplane from a pilot's point of view.
One of the things that we do in the basic design is the pilot always has the ultimate authority of control. There's no computer on the airplane that he cannot override or turn off if the ultimate comes. But in terms of any of our features, even those that are built to prevent the airplane from stalling, which is the lowest speed you could fly and beyond which you would lose control, we don't inhibit that totally. We make it difficult, but if something in the box should inappropriately think it's stalling when it isn't, the pilot can say, this is wrong, and he can override it. That's a fundamental difference in philosophy that we have versus some of the competition.
The 777's computers, which were being tested on the 757, would translate the pilot's instructions into commands to move what are called the control surfaces, movable pieces of the wing and tail that allow the plane to change direction or altitude. This flight was one of a series to test how the fly-by-wire system felt to a pilot when he landed the plane. Like all testing on this new plane, every aspect of the test would be analyzed and discussed to see what lessons could be learned before the design was finalized. The process began with the post-flight briefing. The two pilots reported on how the plane felt as they landed it with the fly-by-wire controls.
Well, you're the third pilot now to have an experience like that, not unique to C-Star U landings, but simply on various landings reporting that your initial flare input generated a result greater than you anticipated.
As you actually do that, you think, oops, you back off, and you always back off too much.
Yeah.
And you end up with a Navy landing.
Uh-huh. That means good landing.
Which, by Frank's definition, is an excellent landing.
In early 1992, the team was under tremendous pressure as weight, cost, and design targets had all been exceeded. They scrutinized every aspect of the project, including travel costs for engineers who were flying from Seattle to meetings with subcontractors in other parts of the world.
We looked at the cost of travel. Right now we travel business class, And for my group, the difference between traveling business class and coach with what we project our tests are going to be, testing support and meetings, is something the order of $700,000. Now we're at a stage of the game where I'm not going to piss my guys off and say you travel coach and everyone else travels business class. So what I'd like to propose is that the 777 program proposes that when we go to UK we fly coach. I think we could save a tremendous amount of money.
I have a guy who's fairly big.
Well, I think,
and
so do I, and I think we can make an exception
and it is
for that.
very uncomfortable for that length of flight and to carry on a meaningful meeting next day.
But we did this for years and years. It's only in the last 5 years or so that we've started to fly business class.
Let's do what Hardy said and pass that and see what kind of reaction you get, and then let's bring it up next time.
It would probably have been unfair to ask if the economy seats in existing planes were too narrow, who designed them, since it was the airlines and not these engineers who decided how many seats to put in a plane. The next item dealt with another thorny subject, office space. With a move to new offices coming up, there was some contention on how the new offices had been assigned.
Some of my supervisors have come into me about the move to Everett and said they thought that all first-line supervisors were in cubes, but they hear that some first-line supervisors are in offices.
Not in engineering?
Yes. Engineering.
Tell me who they are. Because we worked it so that it was supposed to be
On
that
the
way.
floor that I'm on, there are first-line supervisors in offices, and they're not payloads.
Will you tell me who they are?
I'll write it down for you.
Because they tell me that we fixed it. Alan decreed.
We still owe them engineering.
New terminology came thick and fast at this stage of the project. Too fast for some members of the team.
We do that.
MCs, all right.
Okay. Requirements for SDS items and APL, Raj, next week.
I forgot what an SDS item is.
It's a shop distribution standard.
Okay.
We'll also show you the PRR process
With
review.
delivery schedules becoming critical, tempers began to flare when one engineer felt he was being delayed by another.
I've taken a lot of flack over that. Item 8 was the wrong one to put in. The thing that we agreed to put in is when structures returns to data set.
No.
My man told me.
No, we all agreed.
We all agreed. Even showed him the chart.
I showed you the chart.
But,
I showed you which
that's
one.
useless data. Most of it is obsolete. Because
It's not useless data.
It is.
I'm missing releases because you did not transfer on the date the agreed to information.
Because you didn't transfer to me.
What baloney?
Anyways, that's the wrong date.
No, it's not.
I did it.
Oh, okay.
I sat there for 5 minutes 2 weeks ago and explained it. I showed you an example. Everybody jumped on.
Why are you talking to me? I agree.
You guys agreed? Yeah. It's done.
It's done.
In spite of mounting pressures, there was the occasional good news. One of the team reported on a foreign airline whose government was deciding on the purchase of 6 777s. The 777 had been up against its main competitor, the Airbus A330.
And the cabinet had approved the 6. And then they said, well, we think that may not be right. And what we think is we probably ought to add 2 more. So instead of approving 6, they approved 8. And then they also did not approve the 8 A330s. Or sorry, 7 A330s that they were asked to approve.
All right. Nothing like winning.
But there was no disguising concerns about the task that lay ahead. They were just 9 months away from assembling the first piece of the first plane.
Roger, do you have anything else?
Yeah, I have something to say. I'm worried about us. I'm worried about our recovery. We're behind schedule, and what I see is it's going to take a long time to recover. And I think we really need a recovery plan, and I don't think we have one.
Okay.
And I'm
Roger
really
was
worried.
reflecting that we keep telling each other what we really need, and we keep trying to help each other, because in the heat of getting your own stuff out again, the first thing that you let go is coordinating with your, with your colleagues. And Roger is just trying to remind everybody, you can't worry by yourself.
Underlying the building of the 777 was a new kind of organizational philosophy Boeing had dubbed working together. This easily dismissed slogan masked what amounted for Boeing to an internal revolution. For the first time, Boeing would be guided by principles that encouraged, even forced cooperation. First and foremost, there would be no secrets. Information would be shared openly, even when things went wrong.
We had to make some cultural changes. I guess that's the best way to put it. We had to open communications. We had to break down traditional barriers between organizations. We had to come up with forums where the people could speak up, and more open communications and more frankness coming from all levels to management or vice versa.
It was a point of conflict to begin with. An engineer with pride wants to find the solution to his problems. And it's not a natural thing to go out and explore publicly the particular problems you have. You'd like to do it and be able to handle those yourself. So I'd say, yeah, there was resistance at first, but it's interesting what attention can be given to a particular problem like that, communication problem, if you will, in that regard, by just making it okay to do that sort of thing. That the thing to do is to express your problems, get all the help you can. If you're working together, you're going to find that a great assistance in finding the solution, because none of us singularly can do nearly as well as we can as a group. And so I think over the years that's gone away. I think we kind of shout it from the rooftops in our program reviews with large audiences, in our all-team meetings. It's been said, the same words have been used. It's okay. It's almost like celebrate our problems, get them out in the open so we can go work them.
One of the areas of the plane getting a lot of early attention was the interior, the part that would sell tickets. Less visible to the passenger, but equally important, was the design of the cockpit.
The color scheme we kept basic, the same as the 747. And the reason why is because there was a group of people who did a study on color, and they found that warm colors like brown were more inviting to a pilot, and also it kept them more alert. And also we found that brown hid more of dirt than any other color.
But the pride of the 777 cockpit would be the cup holder.
For the coffee cup holder, we come up with concepts first in the drawing, and then we make them out of cardboard. And after we finish our design that we think we like the best, we start casting them. And these are the two that we casted. And so we refine them. So what you have in the flight deck right now is the refined version. And what's also nice, we came up with the idea that it could be removable, because we know that over time that the beverages would spill and stay sticky. You want something that's easily cleanable. And these are some of the samples: pop can, styrofoam cups, airline cup, and they all fit. And we also had to take consideration of the height of the handles, just to make sure that it does fit into the holder itself.
Boeing was also proud of its new overhead bins, which seemed to demand a technology and a jargon all their own.
We have 3 sizes of bins, and those bins can be shuffled to any arrangement to sneak up to outboard monuments. We call them monuments, labs, closets, galleys, etc. But more importantly, in the past, each one of those monuments was very static and had to be tied straight back to structure. In this design, this fore and aft member allows that unit to be translated fore and aft in the cabin on 1-inch centers anywhere in the airplane in prescribed flex zones that allow load path capability in the overhead rail.
The Japanese were expected to be one of the largest purchasers of the 777, but would be among the shortest in stature. Nichols finds a diplomatic way to refer to this fact in describing the design process.
This is an issue with our customers, more so with our Pacific Rim customers than, for instance, European customers, the American carriers. And it's flat the height, it's the ergonomics of the latch, and some of them feel that it's a bit too high. Now, on a pivot bin, it must be this high to reach the latch, but once it opens, then the access to the bin is more than acceptable and more than appropriate in terms of a shelf bin. Where the shelf bin remains static, you hit a latch that's quite low, and the door swings up, and now I'm reaching up here to grab the door. So the latch handle, though our customers have expressed some concern, they've all been through the mock-up, and they understand our design, and to physically move that, that's something that would be, demand a lot of effort, and believe me, we can do anything, but we've, if you will, pounded our stake in the ground and believe ergonomically and demographically this is the right latch.
A part of the plane least likely to be the site of technological innovation were the lavatory seats, but Alan Mullally liked to tell the story of the airline that came to him with a problem.
In the lavatories, when a toilet lid or a toilet seat falls down in the toilet bowl, it makes what they called the big hit sound, the big bang sound. And they found that that was very distressing to the traveling public. So we went to work. We got the mechanical designers, the electrical designers, and the toilet suppliers and makers of toilets and toilet lids, and we got them together, and we started to work on a small device that we could put on the back of the toilet lid. You can see this device right here. And this little device could go on the toilet lid, and we could put another piece out the other side that could hook onto the toilet seat. And we could absorb the energy of the toilet lid and the toilet seat before it hit the toilet bowl. So we could slow the lid down, slow the seat down, so that the big bang sound went away. But think how people are going to feel that when they put the toilet seat lid down, it goes like that. They're going to feel like they're in a quality airplane. Now this is a customer-in toilet seat lid.
The first year's work on the 777 involved designing the new plane. Now, manufacturing would get underway. It would begin as the first component of Boeing's brand new aircraft, a wing spar, began assembly on a giant automated riveting tool. This piece was a long, thin metal spar that would run the full length of the wing. Over the next few months, the rest of the wing would be built up around it. Sylvia Lefferer had the informal honor of initiating the process as she began her job of sealing the edges of the 100-foot-long piece before it was fastened to other components. It was a simple process involving an injection gun and compressed air.
Something's wrong.
At least it was supposed to be.
We got a problem. We got no air right now, so we got to try to get that hooked back up. Well, it did for a minute. Maybe it just bled out.
Once the air started flowing, she smeared a layer of gray sealant along the piece. After years of doing this on other planes, she could produce a layer of constant thickness the entire length of the piece. The work had to be checked by a quality control inspector. Too thick a layer would add weight to the plane. Too thin and it wouldn't seal properly or prevent corrosion.
That looks good. Thank you.
Sylvia's work passed inspection and the pieces were moved into contact with another component ready for fastening. Then there was another small problem. The upper piece of the spar was out of position by a 50th of an inch.
The lower chord's at its locator inboard. The upper chord's 20 thou outboard of its locator.
You mean we just want to index up right there, right?
That's correct.
Couldn't we just take a big seat map and tabulate?
You might as well use the provision of the tool, what it was built to do.
Let's go ahead. To move this way?
Yeah.
Okay, I want to see it. I haven't seen it.
That's what this ratchet handle does here. See, you clamp this here, and then just hopefully move this upper cord inboard.
You ready?
You ready? Ready? Okay. Good. Now watch.
Over in the 777 team's brand new office building, Alan Mullally arrived for work. It was just a few days after Christmas. Mullally hadn't had much of a holiday.
But I came in on all but 2 days. But it was kind of a nice time. It was almost like a time to kind of reflect on the past year and think about the priorities for '93. We had quite a few people working, especially in engineering and in operations and planning and tooling, where they were supporting the first parts of assembly. So I talked to quite a few of the structures engineers and the planners and the toolers associated with structure, just to get a feeling for how they saw it, what their problems were, and challenges and stuff.
Although the team had started assembling the wing, the design of the plane was not finished.
But really, the way we lay out the program is that we stretch that process over nearly 2 years. So what determines what parts are going to be designed is the sequence of when it's going to be assembled. So the actual designing of all these parts is spread over 2 years. So even though we're seeing parts being assembled for like the front spar, those are the parts that were designed first, because those are the parts that need to be built first. But right now, all the payloads area, like all of the bins and the seat tracks and stuff, they're just being designed now because they'll go into the airplane later in the sequence.
The beginning of assembly was a significant milestone in the life of the 777. But now there were only 18 months till a piece of metal in this tool would fly, along with 4 million other components, on the airplane's first flight. And as Mullally looked ahead, he and his team faced an ongoing recession in the aviation industry. How would this affect the fortunes of Boeing's new plane?
It's so important for us that we absolutely not let the current events affect our intensity on getting this program done, because this is such a long-term business and these projects are big and they're made for the future, that we just can't let the anxiousness and the ambiguity of today's environment in any way slow us down. And so we talk about it. We talk about it openly. We talk about every cancellation. We talk about every airline that gets in trouble, every airline that has to go into Chapter 11, bankruptcy, and what it means to Boeing. And we talk about what's happening to Airbus the same way and what it means to us. And it's okay. It's really important that we talk about it. And then we move on to what our real job is, and that is stay focused on developing the airplane for the future. And that's our strength to keep going. But it is worrisome.
The team's morale was at a low point, but there was no stopping the plane-making machine that had lumbered into action. They were committed to building the 777, whatever the challenges, and there were certain to be more of those in the months ahead. Beginning of 1993, in a new factory just north of Seattle, an assembly line awaited the first components of the Boeing company's latest airliner, the 777. It was a significant moment, a culmination of 2 years' work. Three strips of metal forming the front wing spar for the first plane were being riveted together by a huge computerized tool. By the time this plane is completed, there will be 3 million fasteners like this one, holding together several 100,000 parts. 18 months from today, the number one plane would have to fly. But this schedule was all based on faith. Faith in a new approach to plane making that had taken an estimated $1 billion to develop. Previous Boeing airliners had sometimes suffered from costly errors in the manufacturing process. To minimize such problems, Boeing was determined to improve communications among the 10,000 people who were going to design and build the 777. The company would adopt a new management philosophy, known by the slogan, "Working Together." For the first time at Boeing, this plane would also be designed almost entirely by computer. The inspiration for all this came from an unexpected source. The 777 team leader recalled the lessons learned from assembling his children's Christmas toys.
Fisher-Price does the best job of any toy company on making toys that are easy to fabricate and assemble. Fisher-Price makes a little notch in their wheels so that you only can put the right wheel on the right hub, you only can put the left wheel on the left hub. You also use simple tools. So I started saying, you know, what we're after on this program is not just meet cost targets, not just add value to our airline customers, but we're going to do that by doing what Fisher-Price does on Christmas Eve. We're going to make this easier to fabricate and assemble. So one time as a present, the engineering guys, after we started to incorporate all the producibility, they gave me a whole bunch of Fisher-Price toys so I could pass them out and make the points to the engineers.
The task facing the plane makers was enormous, and the outcome was by no means certain. Pieces of this plane would be made all over the world. In Britain and Italy, Canada, and other parts of North America, Japan, and Australia. And there were two key questions. Would the pieces arrive on time, and would they all fit together as planned? This was a brand new plane, made with new materials, guided by computerized electronic controls, and powered by two of the biggest jet engines in commercial aviation. It would also have the largest rudder in the business, but it was this rudder that would create the biggest cliffhanger of the coming year. The problem started during the design phase. Like all the components, the rudder was designed by a group of engineers called a design-build team. The team included designers and manufacturing engineers, as well as representatives of the company that would make the rudder in Australia. The working together concept was meant to highlight problems quickly and eliminate arguments as the problems were solved.
But legally, the 777 legally...
But tempers rose when the rudder design was changed after the Australians had already begun making it.
Process spec deviation.
Excuse me, what I'm saying is a process is defined right now, and that's what we have to work to. And
but the process right now says we got an X-ray.
That's right. We're not going to. Well, I'm just telling you that you have to, you conform to the process as it's defined.
Can't fit it in the room.
Well, I'm just telling you, that's something you have to contend with, and that's why, you know.
That's why we want them to buy.
In a computer analysis, Boeing had discovered that the rudder might develop a troublesome vibration under certain flight conditions.
You're looking at a 10 to 15% increase in rudder stiffness, or in the total loop stiffness, to solve the problem. I'm going to head down to Australia and face the team NASA aren't happy with it.
The teeming masses were the engineers and executives of a small company in Melbourne called ASTA. ASTA had won the contract to build the rudder. Initially, they were delighted.
It's a bloody big job.
They were much less delighted when they got the news that the design was being changed after they were already underway on the prototype. The rudder consisted of many carbon fiber layers laid in a precise pattern and then baked in an oven. Much of their effort to date was now wasted.
I was cheesed off the blazes because of this change. And I'm not exactly that happy today because we set out to achieve a whole series of things with this particular rudder, skin. We'll achieve most of them, but probably the thing that worries me a little bit is that the configuration will change, and it's going to change fairly dramatically. And we still have to deliver on schedule. We've got a requirement to deliver this rudder in the middle of next year, and if we're late on that, it puts Boeing in a bind. And we don't want to do that if we can possibly avoid it.
In any large airliner, the rudder plays an important part in controlling the sideways movement of the plane. In the 777, powered by just 2 large engines, the rudder had a particularly important job to perform.
On this particular airplane, the key task is to allow us to keep the airplane flying in the right direction if we lose an engine on takeoff. It's with a large twin engine airplane, it's a key part to making the whole system work.
The problem was an unwanted vibration involving the rudder and the piston that would move it, called an actuator. ASTA was now behind schedule, but the rudder was such a key part of the plane, it had to be delivered on time or it would hold up the whole assembly and testing process. The ASTA team met to discuss the situation.
What we really have to address is quite clearly the effect of all these changes that are being brought onto us by Boeing. Lovely company though they may be, they've given us a real problem insofar as building this rudder to schedule, because the changes effectively are the skin gets changed by the addition of something between 2, 4 or 6 strips or plies of tape plus some additional fabric. The actuator fittings in the actuator area become titanium, and there is a whole lot of extra machining on some of the other ribs.
There were major concerns at Boeing over whether or not the rudder would be delivered on time. Any delay could throw the whole plane off schedule. As the newly appointed Director of Engineering, Ron Ostrowski was worried.
It complicates schedules for certain, because we wouldn't have anticipated having this problem this late in the game. We wouldn't want it this late. So, like ASTA in Australia trying to produce the rudder, if we have to reinforce it, it affects them. But these things crop up, you know. There will never be an airplane that's perfect right out of the chute. I mean, it's too complex a vehicle to ever expect that to happen, and changes occur, and we have to just recover from those as they happen.
We've had 2 major redesigns so far, and whilst this one looks good, the previous one, the solutions there look good. Hopefully this one's better and this solves the whole problem, because after this, I don't know what the hell we would do if there was another stuff-up.
Another design change, or stuff-up as Tyler put it, was all too likely. Only time and further testing would tell. In Boeing's own plant, north of Seattle, a giant machine was lumbering into action to assemble the first plane. Within a 30-mile radius, Boeing had a number of plants that were making various components for the plane. The components would then be shipped to the main plant for assembly. This is one of the largest single pieces of the plane, a carefully shaped aluminum wing panel stretching 100 feet across the factory floor. The plan was that major sections of the plane, starting with the wings, were to be assembled from hundreds of smaller parts, which would be milled and shaped in the various Boeing plants. The larger sections would be transported from where they were built to the final assembly line. Between each of these stages, the growing plane would be moved from one part of the assembly line to another by a series of enormous cranes. In final assembly, the last stage before the plane left the building, the 777 would acquire its two huge engines. But that was still 9 months away. As the first wing took shape, individual pieces were being sealed so the interior of the wing could act as a fuel tank. Glenda Barnes was one of the wing sealers. The working together approach had definitely affected her job compared to the way things had worked in the past.
I'm a sealer, and if there was a certain bracket such as this one that I knew as a sealer that did not need to have seal on it, but the plans as of now said to seal it. Well, before, I would have to submit a request stating why. Then that would have to go from one place to the next. And by then, there's 2 or 3 airplanes that's out the door, but this bracket is sealed. Now, I can pull together with the other team, and I wouldn't have to seal this bracket today. That's how fast some things can happen now. Say after I have done my first 2 processes, then I have to call quality control to come and look at my process. And then they thoroughly go over it to make sure I have sealed in every place that I should seal it. And if I haven't, they will tape it and let me know. And if I have, they will give me the okay to go ahead to the next process. So, I get upset sometimes if I miss something, but we all have those bad days and those good days. So, and they are there to find those things that I may have missed.
Boeing calculated that their new methods had meant an 80% reduction in the sort of errors and changes they had experienced on previous planes. The floor beams had come together with an accuracy that was down to the 4th decimal place. They held the seat tracks, which were made of aluminum, except in the galley areas where a corrosion-resistant titanium was used.
The reason it's more subject to corrosion is spillage of hop, Coca-Cola, beer, wine, that type thing. It's very corrosive to the aluminum metal, but not the titanium. You want to make sure that the seat is always held. Whatever in the seat, this is one of our, and I know it doesn't look like very much, but it's a very concentrated area for stress when the seats, in a crash load or something like that, it's very difficult. You have to make sure that you can survive a 16G crash.
In the past, the designers in their offices would have designed a component and then washed their hands of it once the drawings had gone to the factory floor. Now, they were involved throughout.
That's really interesting there. We have some manufacturing engineers working with the mechanics. Now, these guys are from the office building, the engineers from over there, and they're coming out talking to the mechanics, something that you would never see in the past. It is absolutely the only way of doing business. Before, I couldn't find an engineer. And now today, I have to ask them to leave so we can build. They have to just quit designing so we can build.
The floor beams were made of carbon fiber composite, very light and very strong. The guiding principle in the design process was building a plane that was as light as possible to minimize fuel consumption and reduce running costs. Wherever possible, the team looked for lighter materials that could substitute for more conventional ones. But in one case, this got the 777 team into trouble. The design of some parts of the plane called for using a new metal alloy called aluminum lithium. Aluminum lithium was to be used in a whole range of areas in the plane. It was expensive, but it was also much lighter and helped the plane meet its weight requirements. But long after the decision had been made to go with the alloy, they discovered a problem. The new metal developed small cracks when it was drilled.
Cracks are a very sensitive issue, as you can imagine in airplane design, because we go to great lengths to not only not have cracks, because cracks usually mean that the crack can propagate or get bigger. Plus we go to a lot of detail to make sure that if the crack does get started, that we have ways of stopping the crack so it doesn't grow. It's just part of our normal design process. The The issue we had with aluminum lithium was that for the applications we were using it, the cracks were okay, technically, but you could see the crack. So how would the customers feel about that? They could see the cracks. Now we'd have to say, on these parts, Mr. Airline, the cracks are okay. And they would have to figure out how to communicate that to all the people that interface with the airplane.
It was time for a decision. Already, the factory was preparing to manufacture parts with aluminum lithium. A meeting was called of all the engineers involved. Before the meeting, the halls were buzzing with rumor and comment.
We're talking about cancellation costs like $2 million for much of the application.
And I think on aluminum lithium, we all had both opinions in our minds at the same time. It'd sure be nice to just go ahead and get that weight in the bag and done. It would sure be nice not to give the airlines and ourselves an extra problem. So you got to be very careful not to make up your mind and let all of the different sides of the issue get out in the open, and then collectively use your strength to make the decision. So the way we try to get the best decision is to get all the pieces out on the table, see what's new, see what that means to us, can we do something about it or not? And then usually that thorough discussion leads you to the right direction.
You're going to have parts here that sooner or later is going to be discovered. Major or primary structural components like Section 12 rib stiffeners, which the airlines for 30 years or 35 years, whatever it is, when they find the crack, they figure they don't fly till it's fixed, and it's a whole. I don't know how big the crack's going to be after 5 years or 10 years, whatever it is, but yeah, the potential here of developing multiple numbers of parts that are going to have minute cracks in them, and to the airlines, that's not an acceptable structural configuration for the airplane.
It's acceptable if Boeing says it's acceptable.
You've got a basic material characteristic you know about already. For example, you know you can't use it in sheet. You know you can't use it in plate. You know you can't use it in some kind of extrusions. 2 more just fell off for whatever reason. You know, the handwriting's on the wall. Like, it's just something that I think you need to look at.
The data's on the wall.
The data.
Maybe I'd like to say a few words since Brian has had a chance to talk about this. The fact is now is that from a technical point of view, I would not put this back on the airplane if I had a choice, because we know more than we do now when we made the decision. On the other hand, I do remember that 280 pounds are still an extremely valuable weight saving for this airplane. And if we take this 280 pounds out, then I don't know where I'm going to get it. We've worked extremely hard to save weight, and we're going to continue to work hard to save weight. And so it's a balance.
Yeah, I think everybody here is aware of the big issues. I mean, it's going to come down to cost and weight versus economic risk.
There's the economic risk, and the worst thing is having to explain this to the airlines forever. I think that's the problem with the preferred airplane.
But it's not black and white, and
right.
And if we were 12,000 pounds ago, it'd be a different situation than we are today.
Yeah.
The decision to remove the aluminum lithium emerged almost by stealth, as the group moved imperceptibly from discussing what would happen if they removed the alloy to planning how they would manage without it. Mullally had achieved the genuinely unanimous decision.
We are tightly bound together.
Nobody said this would be easy, right? Creating solutions and balancing of objectives.
The fact is, it was a good decision. There's no question about that. Again, we thought of the customer, which is what we ought to always think of in decisions of this kind. In this case, the material exhibited certain properties that we didn't think were acceptable. And it wasn't a safety issue at all, but it was a quality perception relative to those imperfections. And we decided until that material had those imperfections removed, we just didn't feel it was appropriate to put them in the aircraft. So we did.
The repercussions of the aluminum lithium decision were to rumble on for a long time, with particular significance for the work being done in Japan. A group of Boeing managers, led by Vice President Neil Standall, traveled to Japan to visit several companies that were making parts for the 777. The trip was a mixture of corporate relations, making the Japanese feel appreciated, and checking up on the parts that would soon be needed in Seattle if the plane was to stay on schedule.
It takes, as you well know, a lot of capacity, both in people and in equipment, to build an airplane. So you want to spread that, if you can, across good foundation or good suppliers. The other reason is for sale benefit, like in dealing with Japan. They buy a lot of our airplanes. They're the biggest buyer of the 747, for example. So we want to have a relationship with the Japanese.
The Japanese were manufacturing 20% of the parts for the 777. Some of these were supposed to have been made from aluminum lithium, including key components of the wings called in-spar ribs. Nippy, the company making the ribs, had scrambled to redesign their machine tools so that another metal could be used. These trips turned executives into 24-hour-a-day workaholics. Business and noodles became hopelessly intertwined. The group was thinking ahead to its visit to Nippy just 2 days away.
I have the materials for Nippy in my briefcase.
Now, when did Nippy ship the in-spar ribs?
On the 30th.
Have they arrived in Seattle?
Yes, they have.
I saw it. I like that.
You can eat sushi with fingers, too. Try it sometimes, it tastes better.
I've ruined 26 neckties, and now she tells me I can eat with my fingers.
Yeah.
You bring the bottom end up, and then it doesn't slap around.
I see you slurping. Let's all watch Neil slurp it.
Let me do it?
Yeah, I want you to do an extraordinary. Not all those. You'll never. Wait a minute.
I bite them off.
No, you're supposed to slurp them. Oh, look at that.
Now I know why you got to be a vice president.
Yeah.
Couple more beers.
Junkie got to.
I encourage you.
Many people, including some employees, wondered why Boeing had involved the Japanese at all. Building large aircraft was one area of technology the Japanese had not yet developed. Yet here was Boeing operating on what some people called an open kimono policy. But for the 777 team, this collaboration provided access to high-quality heavy engineering and equipment. Kawasaki had constructed an entire factory just to make parts for the 777 fuselage, and part of the purpose of Standall's visit was to attend the opening ceremonies. No such occasion could be allowed to pass without a Shinto religious ceremony. This was a significant event. A priest might receive several $1,000s for a service like this, in the hope that the gods would look favorably on the machinery and ensure that it ran smoothly in the years to come. While Standall looked out of place with his Japanese colleagues, he had done his homework when it came to joining in.
Good job. Bye. Did you get your little cedar box?
No, I didn't.
I'm going to take this home for my wife for an Easter gift. We don't get a chance to go shopping, so this is going to be your Easter gift. Somebody took my original one, so I went and got another one.
The next stop was a visit to see how things were going on the passenger doors. The new design methods had made it possible for all 8 doors on the plane to have many parts in common, which saved time and effort in the manufacturing process. In their relations with the Japanese companies, Boeing had to take careful note of the cultural differences between Japan and America. As Standall and his colleagues toured the various factories, they sometimes found problems that had to be dealt with as tactfully as possible. One of these became a worry.
About a month ago, we discovered a problem, brought it to their attention. They told us what they were going to do to resolve it. Things weren't happening. We met with them last week. That was one of the reasons we came over early. They showed us what they were doing, and it was unacceptable. We expressed our concerns to them, told them what was wrong. We had our people work with them on again, off again during the week, and we were not getting anywhere on resolving this. So we asked for a meeting with the general manager, and that meeting could have been very difficult. And as it was, and I couldn't sleep because I was worried about it. Mr. Blakely was worried about it. Neither one of us slept well. And we went in the meeting, had a good open discussion, and so we were relieved. But it could have been, what next if we, where do we go next if we fail here? So we were worried. And I think that, that speaks of the relationship we want to have with them. If we were whimsical and didn't care, we would have gone to bed and gone to sleep, but we care.
The following morning, the group visited Nippy in Yokohama. While the bus was on its way to the plant, the workers were already in the middle of their compulsory morning exercises, surrounded by the 777 in-spar ribs the company was building. Standall's visit to Nippy was partly to thank them for staying on schedule in spite of the changes in design and material. He presented the company with a certificate of thanks from Boeing's senior management. As Standall and his colleagues left the factory and headed back to Seattle, they had mixed feelings. Satisfaction at seeing how well the Japanese had learned how to build airplane parts, mingled perhaps with concern about how long it would take before the Japanese would be building airplanes on their own. In Australia, things were going badly with the rudder. The much-feared stuff-up had happened. Boeing had decided on a third major design change to compensate for the rudder vibration. It was another major setback for ASTA.
We've got a lot of major tools either completed or nearly there. And this last change is probably going to affect at least 65% of our tooling program, and we've got some 600 tools. Anywhere from the large layup mandrels like you've seen to some of the big, huge assembly jigs to put the thing together. And it changes a lot of it.
To soften the blow, Mike Voetland from Boeing arrived to explain the changes in person. It was a difficult job at best, but it was made worse by the fact that Boeing's engineers were still tinkering with the design as he was flying to Australia.
I think we need to have a telephone conversation with Seattle to find out between the time we left and the time we got down here if there's anything that's changed.
Yeah, we can.
Now the bad news is, as you all know, we don't have a lot of time left. And I looked at the schedule last night when we got in, and it tells me that we have about 5 months and 3 weeks to complete this hardware, which is a task that I would say under normal flow conditions would take about 18 months. So we have quite a challenge ahead of us here because the rear spar.
As the Boeing people laid out the changes, it became obvious to ASTA that their worst fears had been realized.
Are you going to change that rib as well?
It looks like worst case, we hit this rib, and the rear spar. That's the bad news.
That is bad news.
Now there is an attach plate up here, but we didn't quite have the details worked out before I left.
When we all came back from the holidays and we thought we had a nice smooth sailing program once again from the last change, they told us, for instance, several of these parts weren't changing, absolutely not. And so we've rescheduled the program based around that particular assumption, and now, just today, we find out that some of those major tools are changing. The addition to this fifth hinge, the changing to those rear spar mandrels and whatnot, is a big impact. It's going to be an interesting one to manage in the time frame.
Are we going to live with April the 5th?
Sure.
You will. I'm sure you will.
That's a month after we asked for it.
Come on, you guys have to give me some. Yeah. You guys are just... What'll happen is...
We're going to give you a rudder if you're lucky.
Boeing had to keep the pressure on ASTA. The delivery date for such a key part of the plane couldn't be allowed to slip, since it would jeopardize the whole 777 project. But Voetlin was clearly worried that ASTA would not be able to keep to the new and punishing schedule.
What do you now say?
Problem is, the magnitude of the workload is enormous, and the opportunity for things to go wrong is great. And that's why I say that I am maybe a little more pessimistic than what you might hear from ASTA.
Boeing has to have respect for a small company that's essentially, I don't want to say bail them out necessarily, but certainly help them out of a bind. I don't know as Boeing could get through one of these changes like this late in the game, in-house on their own program.
The schedule is based on...
Back in Seattle at the regular critical issues meeting, as it was called, the team was going over the myriad problems that threatened the already tight schedule.
Probably the single biggest item that we're trying to do now is number, whatever it is, 12, panic early.
At each meeting, the team analyzed the case histories of things that had gone wrong.
We looked at the payloads, we looked at the systems, now we'll look at the structure. And I think Wolf made a good point, which we'll start to show up in these next two, and that is you miss your first commitment and then things start to go wrong. Here's an example of a fuel jettison system, find all the pieces here. When they got around to do the installation, somewhat late, there was a problem. This will not accept the vent tube.
The issue there was that the engineers had a design and they'd actually ordered the parts to build it. Yeah, it's really just a tube that comes out of the outboard end of the trailing edge, and it enables the airplane to dump the fuel should it need to return to the airport. When they came to work the installation, which involved other interfaces, then they realized that the details and assemblies that they released prior to that time had in fact an interference problem.
They discovered at the assembly stage that a piece called a nut plate interfered with the fasteners on the vent tube, exactly the sort of thing the new design techniques were supposed to prevent.
What would it tell you to do or emphasize for the future?
Ideally, you'd model in all your fasteners and the nut plates, ideally. However, secondarily, if you work to the schedule and not give up time, that there is more time to recover. Here we've had a situation where we didn't get the installation done, and so the surprise came later. And now it's so late that we're out of sequence.
There's enough detail in the definition as the installation's being built up that the engineer, if he's really paying attention to it, knows he's got a nut plate there. Maybe he's not modeling that nut plate, but if he knows he's got close interferences between parts,
He has to deal with it.
He has to deal with that.
Or he doesn't have any
and he needs
solution.
to model it in that case.
So our long-term hope is that every designer with his ME counterpart gets it to the place where they have an integrated solution, and only they can tell us that, because they're the only ones that know those pieces going together.
Yes. And we had to address that so that we know who's been there. There's a clearinghouse. At times I sit in meetings, and even now, I get thinking from time to time, boy, back on the 767 or back on the 737, this is what I did and it worked, and I get impatient, I want to pounce. And yet with the style we have and the team that we have, we are all in this together. We support one another. We don't pounce on one another. I can remember incidences on other programs where various functions would just be at each other. The parts weren't here and the manufacturing guy needed them, or the design wasn't done so the planners could do it. And they'd be across the table at each other just talking very loud. And I've seen that over many times in my career. And when you sit and look at the style we use, if he's got a problem, that's my problem. So let's go work it.
What do y'all think of Jerry's work?
How about his team?
Huh?
Midway in the year, there was a meeting of the whole 777 team. The only place that 10,000 people could assemble was in the factory, on the very spot where the first 777 would roll out of the building in 9 months' time. The occasion was a reminder of how patriotism and plane making went hand in hand.
How are you? Hi, how are you?
Good.
Morning, Mr. President.
How are you?
Now, will you please join me in welcoming the 777 Division Vice President, General Manager, Alan Mulally.
So good morning to you all. This is the 9th all-team meeting that we've had on the program, and we've come a long way together. It's been 21 months since we launched the 777 with our order from United Airlines. We only have 8 months to go before rollout. We are going to turn power on the airplane in January of next year with a first flight of June of next year. So it's really coming together fast. Today, we thought it would be
At about the same time as the all-team meeting, there was another milestone in the life of the first 777. A whole wing was going to fly, out of the jig in which it had been assembled and across the factory floor. It was 2 weeks later than planned, but everyone hoped they could make up the time in the months ahead.
Well, better see if they all freeze. I can raise the tape then around that. Pop it up. Let's just hang on now. Let's go down. No, we've got the half the distance down.
Before the wing could be lifted, it had to be freed from a series of fixtures on the tool, one of which was proving difficult.
They're going to be a couple minutes, aren't they?
In this high-tech factory, it was a hammer that finally did the trick.
We need to be careful that we don't hurt somebody's finger in pulling that out or damage the tool itself. So we want to be cautious as far as how we drive it out. And right now we're using a smaller drive pin, and it just freed up. That popped, and now she's done. So that's good news.
Our crescendos one after the other. This just happens to be another one subsequent to that one in January where we loaded the spar. Now the wing. Tomorrow we'll load the stub and the keel beam. So we're just one right after the other now as far as the first airplane's concerned.
This is our last locator. Let's go on back over to our positions along the wing again now. We need some people in the mid-span here. Going up. Coming up.
22 on. Okay, this SOB kicked about 4 inches north here at the top edge.
Oh, lovely.
The first inch was the hardest. From then on, it was slowly and steadily upwards.
Everything's went real smooth after we got it cleared from the tool. It was a smooth pull, smooth transition coming over. Both the cabs are working real well together. There's virtually no movement in the wing when they simultaneously move, and that's a good thing to see. We're almost done. We're on the road home. We see the light at the end of the tunnel.
Looking good, Don. Perfect. All right, good job, you guys. There it is, first one.
While wing number 1 was on its way down the assembly line, more wing components were headed for the factory to be assembled into planes farther down the line. Today, at the Auburn factory, one of the long wing panels emerges and emerges and emerges to be trucked to the assembly plant 60 miles north. There were huge logistical problems in getting pieces like this to the factory just at the right time. Not too soon so they took up storage space, nor too late so they held up the process. Like a dinosaur with a second brain in its tail, this 130-foot-long truck needed a driver at each end. There was also a third driver in a van behind to prevent nasty accidents.
I'll pick you up after him, huh?
As accidents on the road involving other vehicles and stuff, we've never had. So that's pretty impressive right there. We've had a couple incidences with just stop signs and stuff, but other than that, nothing. People dynamite their brakes in front of us, so we had to go around them real fast. We had a Porsche that was going to go underneath of us one time, and then we had a motorcycle decide he was going to try it one time, but they quit real quick.
Boeing has other plants across the country. A big plant in Wichita, Kansas made several key parts for Boeing planes that were shipped by rail across the Great Plains to Seattle. It was never a trip without hazards.
One of the problems we've had in the past is on our 737 aircraft that we do not cover. We do not cover the rail car. We've had rifle shots. We've even had an arrow stuck in the side of the fuselage when it was received in Renton. We've done things a little different on the 777 where we actually cover the rail car, so we hope to prevent some of that, although a rifle shot would still go through probably that covering, but there wouldn't be the extent of the damage that we've had on the other aircraft.
More and more parts were being assembled into bigger and bigger pieces as the major sections of the plane began to take shape. The pieces were held together with rivets, fasteners that would hold them to the ribs, and cords that gave the plane strength. This was the largest automated riveting machine in the world. It was controlled by computers. But automated riveting wouldn't work for parts that were too curved or awkwardly shaped. These would be done by hand.
The best things about this job are I'm compensated very well, really, and the atmosphere overall is fairly relaxed. I don't feel really stressed or really pushed, and that's real important in any workplace. The worst parts of it are probably that at times it does get tedious, it does get repetitious, and it gets a little noisy in here. The environment isn't always real pleasant, it gets a little warm sometimes. That's probably the worst end of it.
there are some mechanics that don't like to work on the exterior skin of the airplane because it's easy to destroy thousands of dollars worth of material in a very short time if you're not careful, and some of them just don't like to probably take the responsibility of maybe doing that.
Before complete pieces of the plane left the factory, they underwent an important procedure called an FOE check. FOE for foreign object elimination. Boeing wanted to avoid having a customer find anything rattling around in the plane after delivery. A second set of initials, FOD, refers to foreign object damage. It wasn't a complicated procedure. You tipped a piece on end, banged on its sides, and hoped any loose objects fell out. One did.
We know by analyzing it that the bolt came out of our major assembly area, that in their FOD check they missed it. The pins are probably out of our secondary forward box structure area. That information will be fed back to the mechanics who run the process in those control codes, in those assembly areas.
On the other side of the Pacific, in Australia, the progress of the rudder had reached a more hopeful stage. In spite of all the design changes, the rudder for the first plane had been completed on time and was about to be shipped to Seattle. But there were still one or two tiny problems, like rounding up some missing fasteners.
We're now down to 6. 3 are on their way on an aeroplane, and 3 are probably at this stage being put on an aeroplane to get here in time so that we can fasten them up on Saturday.
Boeing wanted to get their hands on the rudder as soon as possible. They arranged to fly it to Seattle on a 747 freighter. Mike Voetlin of Boeing was in Melbourne to keep up the pressure.
Well, we wanted to, one, come out and congratulate ASTA for the tremendous job they've done. 2, we have some issues that we have to clean up this week.
Money.
And, a variety of contractual issues. And we also want to see the hardware ship out the door. We've been involved in this now for 3 years, and this is kind of the culmination of a lot of effort by a lot of people. And we'd like to see the end of it.
We had to design a special shipping container for it. We actually went out to the airport and measured the door, and we have to cant the rudder at a 45-degree angle and support it in a special way, and push it into the airplane, and then we bring it into Los Angeles, and we have to put it on a truck and truck it up to Seattle on an air ride trailer.
Just when it seemed to be going smoothly, there was a final snag. The rudder in its box bashed a small hole in the ceiling of the freighter. Another first for the 777 began one Sunday morning at 6:18 a.m. The first 2 wings would be lifted into position side by side and attached to the central piece of the fuselage. It would be a crucial test for the new computer-controlled crane system built especially for the job. There was an air of uncertainty about the center of gravity of the wings, since they had acquired a lot of extra weight over the previous months.
We put some extremely heavy components on this wing. We've hung the nacelle strut. We've got the aft diagonal brace installed. We've put an awful lot of systems, not only on the trailing edge and on the leading edge where you can see it, but we have folks that work every day inside the wings, putting components inside the wings. We've got a lot of fuel filters, we've got fuel probes, we've got hydraulic systems, we've got fuel tubing, we've got electrical wire runs inside the wings where you can't see the things that have been added on. So that changes the weight and the balance of the wing from the time that it moved from the seal, test, and paint area. And then we pick it up with all of these added components, and it changes the center of gravity.
No one had ever lifted this much weight with these cranes. Bugs in the computer software began to cause small imbalances in the tension on the 4 hooks, which then caused the crane itself to cut out. Bags of lead shot were used to even out the tension temporarily, but more work would have to be done on the software as soon as possible.
Okay, is everybody happy?
Line yourself up east, yeah, inward. East and west here.
Okay, we're going to hold this for a few minutes while they wipe all their ball sockets.
Once the wings were in position, they were bolted firmly to the fuselage. Then a final quality control check for tightness. Near the end of the year, the 777 team met to celebrate a symbolic milestone. It was the 777th day of work on the new plane. The team permitted themselves 3 quiet cheers as they looked ahead to what the new year would bring. As the first year of manufacture drew to a close, the 777 team breathed a sigh of relief at the progress they'd made. But what they had done so far would later seem simple compared with the upcoming task of installing and testing a whole new range of hydraulic and electronic systems. And then would come the testing of the 2 huge engines that would have to lift the plane off the ground. Time was of the essence. For now, that first flight was just 6 months away. It would be one of the most complex machines ever built. It would take 10,000 people and nearly 5 years to build it. It would cost an estimated $5 billion. Success was anything but certain. The plane would contain more than 4 million parts, supplied by contractors around the world. But would they arrive on time?
Miss your first commitment and then things start to go wrong.
And would they work?
From a technical point of view, I would not put this back on the airplane if I had a choice.
Nothing could be left to chance. This would be the most tested airliner in aviation history. Eventually, lives would be at stake.
There's an apprehension anytime you change technology.
To make it all work, the company would reinvent itself from the inside out. And all of this would have to happen at a time when the world's airline industry was in recession. If the 777 were to fail, the company's future was at risk. Success would keep Boeing ahead of the competition for decades to come. This plane would be built to set a new standard for commercial aviation. This is the story
Ladies and gentlemen, we are now descending and preparing to land. Please ensure that your cabin bag is safely stored. Make sure your window blinds are up, seats are in upright position and your table trays are folded. Thank you.
All right, ladies and gentlemen, we are coming into our landing here at Panama, Florida. What are we doing here? We're coming down through 32 right, and as you can see, we're just making preparations here to come in. We're going to come through Kesbu, Wudom, Sally, and then put her down. Hopefully the weather looks quite clear out there, so it should be a nice landing. Anyway, we'll see you down on the runway, guys. Take care. Hey, Maney, how are you, buddy? Kids waking you up, mate? Not good. Hope you're well, mate. I'm going to be jumping on Twitch later on. What's wrong with the nipper, mate? Hungry? I hear you, mate. I hear you. Working on your Daisy empire. Hope you're well, mate. Yep. Trust me, mate. I had 3 of them, all within a year of each other, nearly. I'm alright, mate. I'm just trying to get things done, mate. I've got about 4 weeks to go. I'm scrambling to get all this shit done before winter. Let alone, you know. Yeah, right. I left a comment on Discord. I said it wasn't big enough. We're just coming in for a night landing in Panama, Florida. So dark. It's like one of those nights, mate. It's pitch dark. Very dangerous for flying if you don't know what you're doing. Alright, so they are sending us to 32 left, which is not what we want to do. Thought we were going to go 32 right. Hold on. I could change it. Let's see if I can change it. We want to go 32 RNAV, 32 right. Ah, just as I went to do the request. For the Foo Fighters? Or Coup Fighters? Foo Fighters? Coup Fighters? Is it Foo Fighters? Never heard of the Coup Fighters. Oh, really? The blonde guy? Hang on. Was he the blonde guy? Bloody hell, mate. See, you never... Oh my god, he's only 50. Oh, that guy. Oh, man. I was only watching a clip the other day with those two. What happened to them? I bet he had a heart... Any guesses he had a heart attack, mate? All these bloody... What's his name? Taylor Hawkins. Oh god, they got him in the past members already. Geez, that didn't take long on Wiki. Crikeys. March 25. Causes unconfirmed. Oh shit, they were down in South America. Oh god, I hope he wasn't spanking the powder down there and gave himself a heart attack. Well, that's a bit of a tragedy. Oh shit, hang on guys, we're fucking close to the ground here. Oh, hang on. I've got to focus. It's landing time. Excuse my French. Not for too many years of Alanis Morissette. She's still playing. Oh, you're just a meanie. 50's way too young, dude. I'm 52. That's way too young. I bet he had a heart attack, mate. Any money? Alright, what are they asking me for here? Anti-ice is on. Alright guys, I've got to focus here. I don't want to mess this up. This is a long flight. How long we've got? 17 mile. Let's slow it down. I've turned auto throttle off. Let's get some flaps down. Music off. Let's land this bad boy. My wife and girls are off camping. They're just packing the car now. Me and the boy got the house for 2 nights. Alright, let's do some checks. Auto brake's on. Speed brake. I'll arm that. I'm going to put my headphones on so I can hear what's going on. Yeah, no, I was only watching a bloody thing just the other night with those guys. '72 he was born. Alanis Morissette, she's still going, man. I saw a clip of her last night, actually. Oh, he's got a history here. He OD'd on smack in 2001. So he had a drug history. They were on tour, man. I bet he was up to no good. I'll put money on it. Oh, I put money on it. I put money. You turned 47, dude. Definitely live a rock and roll lifestyle. I mean, I didn't mind her, man. She's put on the weight. You want to see her now? You wouldn't recognise her. She's weird, man. You want to see the way she performs. Like, she doesn't stop. She walks back and forwards. It's like crazy, like she's on something, man. Do a search and you'll see one of her later performances. Who's got a doco? Netflix? Oh, dude, I want to live past 50. You kidding me? I feel like I'm just about to start enjoying life. Sure, I had my party phase, but man, the last 20 years I've been bloody working my ass off. Not much partying to be had. She's the female Bruce Springsteen. Here we go. We're lining up for our landing here, guys. Got to be careful. Watch our speeds. We don't fall out of the sky here. Let me turn the dome light down. HBO. Yeah, I don't mind her, mate. I didn't mind Alanis. She was good when she was younger. I don't really rate her anymore. Like I said, I saw her live. She's a bit weird, to be honest. Who put her on? Was it Madonna that freaking helped her get a break? It's one of the bigger female artists gave her the break. I love those rockumentaries though. My favourite doco genre are the rock docs. Let's get down to 2,000 here, guys. And then I've got to go and help the missus pack a car. Okay, elevation's only 15. Let's get some more flaps down and let's take it down to 2,000. Put this girl down on the ground. Okay, we're on the right. I can see the runway. Oh, she is Canadian? Yeah. Well, can't blame her for that, can we? A lot of Canadians, man, that made it big in America. But hey, you want to put a wager on how the old drummer died? I put money on it that he died of a heart attack. I reckon he was spanking it down there in South America. They were due for a concert, mate, down there. I always come in a little slow with this plane. This is easy to freaking underpower. Yeah, I put money on it. Heart attack, mate. There has been so many heart attacks. And I hate to say it. I won't say it. We just lost a famous cricket player over here, man. He was my age. And he died. He was like one of the best cricketers in history. He was a bowler. Another heart attack. Heart attack. Makes me paranoid, mate. Every time I get heartburn, I'm like, oh God, I'm having a heart attack. You get to our age, man, you freaking got to be careful, dude. You can't behave like you used to. Alright, they're telling us to go to 2000. Oh, yeah, I don't know. I reckon that COVID might have got him tempted, mate. He was down in South America. Someone offered him a nice big baggie. You're going to say it was totally innocent, are you? And he's a bloody drummer. Have a look at him. Nah, don't buy it, mate. I don't buy it. All right, gear down. I'm calling suspicious. I mean, Foo Fighters, they always kind of made out they were like pretty clean cut. But, I mean, Dave Grohl always made out as though they were clean cut band. But, yeah, right. Whatever. Who you kidding, Dave? We know what you boys are up to on tour. Alright, we're ready to land. We can't screw this up, guys. We've just travelled down from your way. We just came down from Boston. Oh, you saw him? Yeah, that would have been good. Alright, I'm going to go on auto now. I'm going off auto, we're on manual now. Hey Maney, I'm gonna email you about my itinerary. They're telling me to go left. Didn't they give us permission to, shall we swing over to the left? Why are the lights on? No, I'm not swinging over to the left. If they got it wrong, that's their problem. Such a genuine dude. Wow, he was no angel though, mate. Don't bloody give me that bullshit. Mr. Nirvana. He's just, he probably just knows his limits, you know? I mean, he is a nice guy. I enjoy his interviews but you know, we don't know these people, mate, from a bar of soap, do we? He could be a complete arsehole. Coming in freaking hot, boys. Coming in hot. Hang on, mate. I'm not going to look at text for a bit. Gears down. Check. They're going to spit it when I land here. They're going to go, you weren't freaking... We didn't give you perms. I'm like, well, hang on. You didn't get back to me before when I asked you. To land here. I wonder if that light, because the reds there, were on the wrong runway. Tell me about it, chat. Is that what that means? Made it, boys. Piece of piss. Where's the airport? Where's the actual airport? Hang on.
Engine off, time locked.
Well, thanks very much, guys, for hanging out on the flight. I've got to go and help the missus. If you're around tonight, matey, I will be on Twitch. Not sure what we're going to do, but we'll get up to some shenanigans. Alright, guys. That was a nice, pleasant night flight. I think I can see the airport over here on the left. Yeah, mate. We'll see you then, buddy. Thanks for hanging out. Thanks for popping in and saying hello, mate. What are you still doing? Oh, well, it's still pretty early. Is it 1 o'clock over there now? 1 in the morning. Hey, have you still got snow up there? Oh, they didn't complain. They said we were cleared to land. No, they haven't said anything. I can't get any sense out of them. They're not answering me. They're rightly pissed off. All right, guys. If you enjoyed the flight and you haven't subbed already, hit that sub button and we'll run another flight. Maybe I might run another one today after this one. And then I've got to jump on the old Twitter later. We're just going to drop our guys off just here. Thanks for joining us.
Ladies and gentlemen, please keep your seatbelts on until we reach the gate. On behalf of the entire crew, we would like to wish you a Merry Christmas and a Happy New Year. Thank you for choosing to fly with us today.